Hello there, and welcome to the Sleepless Scientist, a calm corner of the universe where your thoughts can loosen and knowledge drifts softly through the night like a lullaby. Tonight, we'll explore something quietly astonishing, a truth so familiar it's easy to overlook, that nothing can move faster than light. Yet within that single rule lies the foundation of everything: time, space, energy, and the delicate fabric that holds the cosmos together. Before we begin, I'd be truly grateful if you took a brief moment to like this video and subscribe, only if these gentle explorations bring you a sense of calm and curiosity. And when you're ready, let me know in the comments where you're listening from and what time it is for you right now. It's always a quiet wonder to see how far this little circle of dreamers stretches across the world, each of us awake beneath a different sky. So, if you'd like, dim the lights, let a soft breeze or the hum of a fan fill the background, and settle into comfort. Together, we'll begin our slow journey through the story of motion, light, and the quiet boundaries of the universe. And if your thoughts begin to wander, that's perfectly all right. Let them drift. The story will wait, unfolding gently in the dark. Let's begin with a question that sounds deceptively simple. Why can't anything move faster than light? You might think of speed limits as something imposed by humans, little signs on roads with numbers we can disobey if we're feeling especially reckless or late for a meeting. But the speed limit we're talking about tonight isn't painted on a signpost. It's written into the fabric of the universe, not as a rule we enforce, but as a truth that reality itself obeys, quietly, always, everywhere. The speed of light in a vacuum is about 299,792 kilometers per second. That's so fast it could circle the Earth more than 7 times in just 1 second. And yet, strange as it sounds, it's not the speed that makes it special. It's the fact that it's a maximum, a boundary not even the fastest spaceship, the most powerful rocket, or the wildest sci-fi invention can break. Not because we lack technology, but because the structure of space-time itself will not allow it. And that idea, it shifts everything. Because from that one truth, that light has a maximum speed and nothing can overtake it, follows a deep rethinking of how time flows, how cause and effect work, and how space is not a stage we live on, but a thing that bends, twists, and evolves with us. If you've ever stared at the stars on a quiet night, you've already participated in this mystery. The starlight you see isn't from now, it's from years, even centuries in the past. Light travels fast, yes, but not instantly. That glimmer may have left its star when Mozart was still alive, or when the first dinosaurs hatched on Earth. Every time you look up, you're peeking into history. In a way, your eyes become time machines, not by leaping forward or backward, but simply by receiving light that had a very long journey. But the story of the speed of light doesn't begin with telescopes or rockets. It begins with motion. Because to understand why the universe has a speed limit, we first need to realize something simple, yet astonishing. Everything is always moving. It may not feel that way at first. Right now, perhaps you're lying in bed or curled up on the couch. The world around you may feel still. Your body might feel at rest, but dig a little deeper and motion is everywhere. Atoms in your body vibrate with heat, even when you're still. Electrons swirl around atomic nuclei at speeds we can barely imagine. The Earth itself is spinning at over 1,600 kilometers per hour at the equator. It's also orbiting the Sun at around 107,000 kilometers per hour. And the Sun is orbiting the center of the Milky Way, dragging all of us with it at a blazing 828,000 kilometers per hour. That galaxy, it's moving too, drifting within a cosmic sea, tugged by gravity, nudged by the subtle architecture of dark matter. You're not just lying still. You're a passenger in a grand, unending motion, and you always have been. Stillness, it turns out, is an illusion, a kind of visual lullaby our senses hum to make sense of a world too chaotic to follow completely. Even time, which we so often think of as separate from motion, is deeply tangled in it. Time doesn't just pass, it is a kind of motion. The motion of things changing, of atoms rearranging, of memories forming. Without motion, time wouldn't make sense at all. And without time, nothing could happen. No story could unfold. Not even this one. This is where the mystery deepens. If everything moves, then why should there be a maximum to how far something can move? What makes light special? And more curiously, if light is the fastest thing, why does it seem so calm, so soft? Why does it appear to drift gently through our world, like a quiet whisper rather than a scream? Perhaps because the deeper truth is this: light is not just something that moves through the universe, it is something that helps define what the universe is. Its speed isn't just a limit, it's a boundary between what can happen and what can't, between what can be known and what must remain out of reach. It doesn't just illuminate, it shapes the contours of time and space. As we drift into the next part of our journey, we'll begin to explore this idea more deeply. We'll see how light's speed holds time in its arms, how it weaves the rhythm of cause and effect, and how it guards the doorway between possibility and paradox. So breathe in and let the thought settle. You're living in a universe with a built-in rhythm, a pulse measured not in heartbeats, but in light. And that rhythm never breaks pace. Let's begin with something so quiet, so ordinary that we often forget how strange it really is. Stillness. Right now you may feel still. Maybe you're lying down, tucked into bed or curled gently into the couch, with the soft hum of a fan or the distant whisper of nighttime sounds outside your window. Maybe the room around you feels calm and unmoving. The air is still. The books on your shelf haven't stirred. The walls haven't creaked. And yet, the truth is that nothing is truly still. Stillness is not a state of reality, but a trick of our senses. Beneath the surface of quiet, everything is in motion. Start with your body. Even as you rest, your heart pulses in a slow, steady rhythm. Blood flows, carrying oxygen in intricate loops. Your lungs rise and fall imperceptibly. Within you, cells bustle with activity. And inside those cells, even more movement. Molecules vibrate with heat. Enzymes rearrange atoms. DNA unwinds and zips back up like careful fingers folding paper. And even deeper, in every atom, electrons swirl in probabilistic clouds. Nuclei dance with uncertainty. There is no such thing as a motionless molecule. If you were to zoom in far beyond anything your eyes could see, you'd witness a world in constant flux. At room temperature, atoms vibrate billions of times per second. Even in ice, where things seem frozen, the particles are quietly trembling. Stillness, as we perceive it, is more like a pause in our attention than an absence of motion. It's the eye of the storm, not the end of it. And that's just the small stuff. Step back, and you'll find that the very ground you rest upon is anything but still. Earth rotates on its axis at roughly 1,670 kilometers per hour at the equator. That's faster than the speed of sound, and yet we don't feel it. Not because it isn't happening, but because it is so smooth, so consistent, that we've never known anything else. Our planet also races around the sun at about 107,000 kilometers per hour, over 30 times faster than a bullet. And the sun, in turn, is being pulled along in a vast galactic orbit, spinning through the Milky Way at nearly 828,000 kilometers per hour. And the galaxy, it too is drifting through a sea of other galaxies, nudged by dark matter, pulled by invisible threads of cosmic structure, slipping softly through the universe's expanding tapestry. Wherever you are, whatever you're doing, you're moving through space at unimaginable speeds. You're a passenger in a vast swirling ballet, and everything around you is too. Stillness isn't real. It's a comfort we borrow from scale. There's something almost poetic in that, isn't there? The idea that even when you lie down and feel completely still, you're gliding at breakneck speeds through layers of movement inside your body, on your planet, across your galaxy. The motion is always there. It's just quiet. And this cosmic hum of motion isn't just something that happens, it's something that must happen. Motion is part of what keeps the universe alive. Without motion, there would be no heat, no light, no chemistry, no life. Even time itself is inseparable from motion. Time measures change, and without change, time loses all meaning. We often picture the universe as a kind of stage, where objects move around while time ticks forward like a metronome. But that image is too simple. Motion doesn't just happen in the universe, it is the universe. Every interaction, every heartbeat, every orbit, and every gust of wind is part of the same endless unfolding. The cosmos isn't sitting still, waiting for stories to happen. It is the story, and the movement is the telling of it. You might think of this like a kind of cosmic breath. In and out, expansion and collapse, a tide of atoms and light that never stops rolling. Galaxies drift apart, stars are born and die, molecules rearrange themselves, and we, brief conscious little flickers of stardust, ride it all, mostly unaware. Even light, which we'll talk more about soon, is always in motion. It has no mass, and so it never stops, never slows. It moves at the fastest speed the universe allows, and because it moves at that speed, it becomes something more than just motion. It becomes the marker by which all motion is measured, like the steady beat of a cosmic drum. But before we get ahead of ourselves, just pause here for a moment in this idea. Everything is always moving. That may seem like a small truth, but it's one of the deepest we know. There is no still point in the universe, no absolute rest. Even black holes, those dark titans of gravity, spin. Even the vacuum of space, which seems empty, flickers with quantum fluctuations. And yet, in this motion, there is a kind of peace. Because even though everything moves, it doesn't always move quickly. Some motions take billions of years. The drift of continents, the dance of galaxies, even the cooling of a star. These are the slowest lullabies in existence, and yet they are motion all the same. And perhaps there's comfort in knowing that motion doesn't always mean noise or hurry. Sometimes motion is slow and patient. Sometimes it is the kind of stillness we feel in a sleeping forest, or in the deep breath of the ocean, or in the gentle rise and fall of your chest as you listen. And so, we begin here, with motion, not as a force to resist, but as the quiet rhythm that underlies everything. A rhythm so steady that it becomes invisible, so vast it feels still, but it is always there, like the earth turning beneath you, like your atoms trembling with warmth, like the starlight that left its home centuries ago and finally finds you. If everything is always in motion, then there is one motion more mysterious than the rest, one so familiar we almost forget it's there. It doesn't push us from one place to another like a breeze or a current. It doesn't shake the ground or jostle the air, and yet it carries us endlessly without pause or permission. That motion is time. You might think of time as a backdrop, a neutral stage across which events unfold. But time is more than that. It's not passive. It's a kind of motion itself, a shifting, ungraspable change that pulls everything forward. It is the gentle ticking of a clock, the slow curling of a leaf, the fading warmth of tea left too long. Time flows, whether we want it to or not. It slips through us even as we try to hold on. But what is time, really? And why does it feel so much like motion? For most of history, time was measured by the motion of the heavens. The sun rose and set, stars circled overhead, the moon waxed and waned. Ancient astronomers used sundials and shadows, and even the dripping of water from carefully carved vessels to track its passing. What they were really measuring wasn't time as an abstract thing, it was change, cycles, repetition, the movement of light and shadow across the land. And even today, in our most precise atomic clocks, time is still bound to motion. A cesium atom, vibrating nearly 9.2 billion times per second, marks the heartbeat of what we call a second. Clocks in any form are just devices that track movement, whether it's the swing of a pendulum, the flow of sand, or the oscillation of atoms. Without change, without movement, time would have no meaning. Imagine a world completely frozen, where nothing stirs, nothing ages, nothing decays. In that world, there would be no before or after. Time, in any meaningful sense, wouldn't exist. It is only through the unfolding of events, the blooming of flowers, the wearing down of stone, the quiet fading of a voice, that time becomes real. This is why some physicists and philosophers describe time not as a fundamental thing, but as a measure of difference. Time is the distance between two states, the ticking between two instants, the unfolding of one arrangement into another. It is not a force that causes change, it is the shadow that change leaves behind, and yet we feel it deeply. We feel time in our bodies, in the quiet creak of joints or the silvering of hair. We feel it in the softness of memories, in the way they blur at the edges as they drift further away. We feel it in photographs, in anniversaries, in the way a familiar place changes when we return after years. We feel it in grief, in joy, in waiting. Time is not just a physical motion, it is emotional, personal. It marks the rhythm of being alive. But here's something curious. In the equations of physics, time doesn't have to move forward. The laws of motion, of gravity, of electromagnetism, they work just as well if you run them backwards. A dropped glass falling to the floor or leaping back into your hand. The math doesn't care which direction you choose. And yet in the real world, we never see shattered glass reassembling. We don't grow younger, we don't remember the future. So, what gives time its direction? That's something we'll explore more deeply in a later chapter when we talk about entropy. But for now, hold this thought gently. What we call the flow of time is deeply tied to how the universe changes. It's not a river flowing past us. It's something more subtle and more profound, the rhythm of change itself. And that rhythm is not always even. Time can stretch and compress. It can slow down depending on where you are and how fast you're moving. A clock on the International Space Station ticks slightly slower than a clock on your kitchen wall, not because something is broken, but because of motion and gravity. This is time dilation, a consequence of Einstein's theory of relativity. We'll get into the beautiful strangeness of that soon, but for now, let it be enough to know that time isn't fixed. It bends, it sways, and in doing so, it reminds us that our experience of time is both real and relative. You can feel this in your own life, can't you? Think about how time drags during a sleepless night, or how it races during laughter. Think about how a childhood summer feels like an ocean of days, while adult weeks vanish in the blink of an eye. There is no universal clock that beats the same for everyone. Time is elastic, emotionally, physically, even cosmologically. Some have called it a river, always flowing forward. But maybe it's more like a breeze, invisible, felt rather than seen, sometimes gentle, sometimes fierce, always passing through us, always moving us whether we notice or not. And so, time becomes the most essential motion of all. We don't watch it from a distance, we move through it. Or rather, it carries us, like leaves on a stream. It is the motion we cannot pause, rewind, or outrun. And in that soft, unstoppable pull, we live every moment we are given. If motion is the heartbeat of the universe, then time is its breath, continuous, rhythmic, and full of change. So as we continue this journey, Let's remember that time is not just what we measure with clocks. It is the unfolding of everything. It is the soft rustle of pages turning in a book you're not yet finished reading. It is the sound of rain that started long before you noticed it and will end long after. It is the thread that ties together every heartbeat, every thought, every star being born. Time is always moving, and so are we. There's something comforting about the idea of now, a shared moment, a universal present. When you think of now, you probably picture something solid, a point in time that everyone, everywhere is experiencing together. It feels obvious. After all, you and I are here in this moment, aren't we? Me, speaking softly through words shaped by thought, and you, listening gently, perhaps with closed eyes and a slowing breath. Surely this moment, this now, is real. And yet, in the strange, precise world of physics, now begins to unravel. In our everyday, livers, we treat time like a string of events, evenly spaced. We imagine there's a single, ticking clock in the sky, keeping track of every instant across the universe. But that image, soothing as it is, turns out to be an illusion, an artifact of how we, as humans moving slowly on Earth, experience time. According to Einstein's theory of special relativity, simultaneity, the idea that two things can happen at exactly the same time, is not absolute. It depends on where you are and how fast you're moving. The order of events that seems obvious to you might appear entirely different to someone speeding past at a significant fraction of the speed of light. Let's say you're standing still on a platform and a friend zooms by on a train, moving close to light speed. A lightning bolt strikes the front and the back of the train at what seems to you to be exactly the same moment. But to your friend on the train, those two bolts didn't strike at the same time. One came first, the other later. Not because of faulty perception, but because of how time and space shift depending on motion. That's not a glitch in the system. That is the system. This means that now is not a universal truth. It's more like a local agreement. What you consider now depends on your position, your motion, and your frame of reference. Two observers moving differently through space might completely disagree about what's happening at the same time, even about whether events are simultaneous at all. And that's not just theory. We've confirmed it with experiments. Fast-moving particles decay more slowly than stationary ones. Atomic clocks flown around the Earth come back ticking slightly behind their stay-at-home counterparts. Our GPS satellites have to account for this effect, constantly adjusting for the fact that time ticks differently high above Earth than it does down here. If they didn't, your phone would place you miles from your actual location. So where does this leave the idea of now? Perhaps it helps to think of time not as a series of synchronized ticks, but as a landscape, one that stretches in all directions. Each point in that landscape is a moment in space-time, fixed in its place. But depending on where you are and how you move, you might slice that landscape differently. One observer's now is another's then, and someone else's soon. Imagine space-time as a great loaf of bread. Each slice you cut through it is your present. But the angle of your slice, how thick it is, how it tilts, depends on your motion. And others, moving differently, are cutting different slices. There's no single, universal cut that everyone agrees on. The present is not a plane, it's a perspective. If that feels unsettling, you're not alone. For centuries we believed in a cosmic clock, a shared rhythm that kept time marching forward together. It turns out, the universe is less like a parade and more like a gallery. Each moment on display, some closer to you, some farther away, and each observer walking through the gallery on their own path, seeing the exhibits in their own order. But this doesn't mean the world is chaos. It means it's richer than we thought. It means every motion, every perspective, adds another layer to the story of time. To make sense of this, physicists use something called a light cone. It's not made of light exactly, and it's not shaped like an ice cream cone, though it does have a kind of tapering elegance. It's a way of mapping out what events in space-time you can affect, and which ones can affect you. Picture yourself as a tiny point on a map of time and space. From that point, imagine a cone stretching outward into the future. The inside of that cone represents everything you could possibly reach, even if you were to move at the speed of light. It is your realm of influence, your potential. Similarly, there's a cone extending backward in time, containing all the things that could have influenced you. Light from the past, sounds from a moment ago, even gravitational waves that passed through long before you were born. Outside the cones, those are events you can never reach, and can never reach you, not unless something could travel faster than light, which, as we'll see, breaks the universe in uncomfortable ways. Light cones aren't just mathematical curiosities, they define what's possible. They're the architecture of cause and effect. If something happens outside your future light cone, it doesn't matter how fast you run or how long you wait, you can never catch up to it. It's not just far away, it's forever out of reach. So when we say now, we're really referring to something extremely personal. Your now is built from the light that has had time to reach you. It's the horizon of what you can observe. And even as you breathe, that horizon expands faintly, constantly at the speed of light. In this way, you're always moving through a private present, yours alone, shaped by your motion and location in the universe. And so is everyone else. Perhaps that's a strange thought, or perhaps it's beautiful. Perhaps it means that every consciousness is a kind of lighthouse, sweeping its own beam across the sea of time, each one illuminating its own path, its own slice of now, and quietly, unknowingly, overlapping with others. Maybe that's what memory is, a collection of past light, gently stored. Maybe that's what dreaming is, a ripple on the inner surface of your personal light cone flickering between what was and what might be. And maybe that's what makes this very moment special, not because it's shared by all, but because it's uniquely yours. And now that no one else will ever experience in quite the same way. And so, as we prepare to move on to the next part of our journey, keep this thought in your pocket. Time isn't one rhythm. It's a quiet chorus sung by countless clocks, each ticking to its own beat. And now, it's just your voice joining the song. There's a number etched into the fabric of physics so precisely, so universally, that it often slips by unnoticed in its familiarity. 299,792,458. That's meters per second, the exact speed of light in a vacuum. It's not a rough estimate, it's not rounded. That number is, in fact, so fundamental that we've defined the meter based on it. It's the ruler by which we measure reality itself. But let's pause and step back from the precision. Numbers, after all, are only half the story. What does it really mean that light moves at nearly 300,000 kilometers every second? What does it mean for us? For time, for space, for the boundaries of what can be? Imagine for a moment a beam of light leaving the surface of the sun. It crosses the vacuum of space, gliding silently, untouched by friction or resistance, and in just a little over 8 minutes it touches your face. That warmth you feel on your skin at midday isn't from the sun as it is now. It's from the sun as it was minutes ago. Light is always arriving late, but it's the best messenger the universe has ever known. You could say light is fast, but fast compared to what? A plane? A rocket? A bullet? It's faster than all of them, of course, but more profoundly, light is not just fast, it is the fastest. It is the upper limit of motion, not just for light itself, but for anything that carries information, energy or cause. If you want to send a message from one place to another, light sets the speed limit on how quickly it can arrive. And it's not just about light. Photons are simply the most famous of the messengers that travel at this speed. Other massless particles, like gluons or potentially gravitational waves in the form of gravitons, are thought to travel at the same rate. In this way, the speed of light is a kind of universal courier speed. It's how fast influence moves. It's how quickly a cause can ripple outward and become an effect. This is why, when physicists say the speed of light, they often mean something broader. They mean the speed of causality. A way of saying, nothing happens faster than this. No effect precedes its cause. No message outruns its own origin. You might think of it like this. Imagine the universe as a vast, dark lake. If you drop a stone into the water, ripples move outward. Not instantly, but at a fixed speed. The light speed limit is like that ripple speed. It's the rate at which reality responds to being touched. And here's where it becomes even more beautiful. This limit is the same for everyone, everywhere, always. Whether you're standing still or flying through space at incredible velocity, the speed of light remains constant. This was one of Einstein's most astonishing insights. If you chase after a beam of light, it doesn't appear to slow down relative to you. It still moves away at exactly the same speed. That constancy breaks the rules of intuition, but it preserves the rules of the universe. It's strange when you first hear it. After all, if you run toward a thrown ball, the ball seems to come at you faster. If you run away, it seems slower. That's how normal speeds work, but not light. Light behaves differently. No matter how fast you're moving, the beam of light coming toward you greets you with the same, unwavering speed. And that, it turns out, changes everything. Because if the speed of light must remain constant, then something else has to give. That something is time, or distance, or both. When you try to keep light speed fixed for every observer, the only way to make the equations work, the only way to keep the universe consistent, is to allow time and space themselves to bend. And so they do. Clocks tick slower, rulers shrink. Events that seemed simultaneous no longer are. Time becomes flexible. Space becomes curved. And from this flexibility, all of relativity is born. Light, then, is not just a traveller, it is the sculptor of reality. It defines not only how fast things move, but how time flows, how space stretches, and how cause touches effect. It is the needle that threads moments together, the rhythm that holds the universe in sync. And remarkably, light travels this way not by effort, but by nature. Photons, unlike us, carry no mass. That means they don't need to accelerate to reach their speed. They are born moving at the speed limit. They have no choice. They do not speed up or slow down. They do not rest. They simply are. In fact, for a photon, something very strange happens. It doesn't experience time at all. From its perspective, if you could call it that, a photon leaves one place and arrives at another instantly. There is no journey, no wait, no in-between. Its entire existence is stretched across space but compressed in time. For us, it might take 8 minutes for sunlight to reach Earth. For the photon, there was no time at all. This is what happens at light speed. Time dissolves. It's one of the quiet paradoxes of the cosmos, that the thing which shows us the stars, lights our way, brings us warmth, and defines the speed of cause itself, doesn't experience time. Light is timeless. It carries time to us, and yet it has none of its own. So when you light a candle in a dark room or glance at the stars above, remember this. The glow you see is not just brightness. It is information. It is a whisper from the past, travelling the only way it can, and it arrives with perfect constancy, never early, never late. The universe may be vast, mysterious and wild, but thanks to light it is not silent, and thanks to its speed it is not chaotic. It is measured, ordered, and connected by a limit that every particle, planet and possibility must obey. A limit not imposed, but revealed. Not a cage, but a song. There's something quietly humbling about a boundary you cannot cross. Not because there's a wall, or a warning sign, or a punishment waiting on the other side, but because the boundary is part of what makes the world make sense. The speed of light is that kind of boundary. It's not a limit imposed by force. It's one built into the structure of reality so deeply, so thoroughly, that trying to break it is like trying to divide by zero. The math doesn't just say you can't, it says this has no meaning. Let's start with something familiar. Imagine a car speeding down a highway. If you press the gas, it speeds up. More fuel, more push, more speed. The logic feels simple. Apply energy, go faster, and it works until it doesn't. Now imagine pushing not a car but a tiny particle, like an electron. You feed it energy and it speeds up. You keep pushing, adding more energy, and yes, it goes faster, but something odd begins to happen. The more energy you give it, the harder it gets to make it go even a little faster. It's as if the universe starts pushing back, not with a force, but with a rule. In Einstein's theory of special relativity, as an object moves faster and faster, its relativistic mass increases. That doesn't mean it's getting heavier in the usual sense, like piling on bricks. It means that from the perspective of an outside observer, the object resists acceleration more and more. The closer it gets to the speed of light, the more energy is required for even the tiniest increase in speed. And at light speed, the math tells us that it would take infinite energy to reach that point. Infinite, not just a lot, not just very difficult, but genuinely beyond all possibility. There isn't enough energy in the universe to do it. Even if you turned every star, every planet, every quark of matter into pure energy and focused it all into a single push, you still wouldn't be able to nudge a massive object across that finish line. This isn't like trying to leap over a high fence. It's like trying to reach the edge of a horizon that moves away every time you step toward it. The speed of light isn't just fast, it's the asymptote, something you can approach endlessly but never touch. Why? Because time and space begin to bend as you get close. As a particle moves faster, time for it slows down. At 90% the speed of light, time ticks at about half its usual rate. At 99% it ticks at just 14% of the normal rate. And as you approach 100%, that is the speed of light, time for the particle slows to a crawl. From its own perspective, the journey takes almost no time at all. Meanwhile, from the outside, the particle's progress flattens out, as if the universe is stretching its path longer and longer. The same goes for space. Length contraction, another consequence of relativity, means that the faster you move, the more distances seem to shrink in your direction of travel. This isn't a trick of the eye. It's not perception. It's physical, built into the geometry of space-time itself. And this is the heart of the matter. Trying to reach the speed of light doesn't just mean going faster. It means asking space and time to collapse, to twist themselves infinitely tight around your path. And the universe, quietly and without resistance, says, no. It's not a mechanical limit. There's no engine that fails, no tire that bursts. It's a structural limit. Like trying to draw a square circle. The rules of the game simply don't allow it. Massless particles, like photons, don't face this problem. They were never trying to reach the speed of light. They were born there. They exist there. They experience no passage of time, no resistance, no change in mass. They are timeless travellers. But anything with mass, no matter how small, is forever tied to the slower side of the universe's tempo. You might think of it like this. Imagine a river with a current so fast that no boat can match it. Some leaves float effortlessly at its full speed, gliding with the water, experiencing no effort, no drag. But the moment you try to row, a boat, a swimmer, a stone skipping across, you are limited. You can follow the current, even use it, but you can never go faster than it flows. The current defines motion. It isn't something to overcome, it's something to live within. And it's a good thing too. This speed limit isn't a cruel restriction. It's what keeps the universe coherent. It keeps causality intact. It prevents paradoxes from unraveling the fabric of reality. Because if you could exceed the speed of light, you could, in theory, arrive before you left. You could send messages into your own past. And with that, the stories of time, of memory, of consequence begin to fall apart. By placing a speed limit on how fast information can travel, the universe protects the order of things. It creates a kind of cosmic etiquette. First cause, then effect. First the drop, then the ripple. First the spark, then the flame. You don't get to see the answer before the question is asked. And so, the speed of light isn't just about motion, it's about meaning. It is the way the universe whispers, things happen in order. One moment gives birth to the next. It doesn't stop you from dreaming about faster, but it quietly, gently and firmly reminds you. Some dreams belong in the realm of metaphor, not mechanics. So sleep, and let that boundary rest where it is, not as a wall, but as a rhythm. A cosmic tempo, too swift to surpass, too deep to break. You are part of a universe that dances just beneath it, and in that, there is beauty. Imagine lighting a single candle in a vast dark field. The flame flickers gently, and around it, light begins to spread. Not in every direction instantly, but outward in a growing sphere, soft, steady, measured. That expanding shell of illumination defines a kind of boundary. Everything touched by the light has been reached by the candle's influence. Everything beyond it is still waiting in the dark. This is more than a poetic image. It's a window into one of the most profound structures in physics, the light cone. In the language of space-time, a light cone is not a physical object, nor something made of photons or rays. It is a map, a way to chart the possible connections between one event and every other event in the universe. It begins with a single point, here and now. From that point, imagine a cone extending outward through space and forward through time. The interior of that cone represents everything you could possibly influence, even if you sent out a signal at the speed of light. There's also another cone stretching backward in time, reaching into the past. That's your past-like cone, the region of space-time from which light, or any signal travelling at light speed or slower, could have reached you by now. The stars whose light is just now arriving, the supernova that exploded 1 billion years ago but only now becomes visible in your sky, the whisper of a gravitational wave that finally passed through your atoms. These are all part of your past light cone. They have touched you. They are part of your story. Everything outside both cones, outside this hourglass of causality, is causally disconnected from you. You can't influence it. It can't influence you. Not yet, and not ever, unless something can move faster than light. This might sound abstract, but it isn't. It defines the very possibility of cause and effect. If something happens outside your future light cone, no matter how advanced your spaceship, no matter how patient you're waiting, you can't get there in time to change it. And if something lies outside your past light cone, it didn't leave any trace in your world. It might as well not exist, not because it's not real, but because it's forever separate. In this way, light cones draw the edges of connection. They are not walls, but they are limits. They are how the universe organises its events, not by choice, but by geometry. Not by preference, but by the deep structure of space-time. If you've ever watched ripples on a pond after a stone falls, you've seen a metaphor for a light cone. The expanding circles mark the boundary of influence from a single splash. A leaf floating nearby will be nudged. A pebble beyond the reach remains still. The same holds true for every event in the universe. Whether it's the birth of a star or the blink of your eye, each one has a zone of reach, a growing shell of possible consequences, and a distant region that will remain untouched. And these cones aren't fixed in the sky. They belong to each event, each point in space-time, each moment. You have your own light cone. So does every heartbeat, every whisper, every spark. They nest inside one another, layer upon layer, like echoes inside echoes. This also means that our experience of time is shaped not just by motion, but by connection. What we can know, what we can influence, what can surprise us. Events that are elsewhere in space may lie within our light cone and yet arrive from a vastly distant past. Others might be quite near in distance, but beyond the edge of reach. A planet circling a star just outside our observable universe might be close in terms of location, but far in terms of time. Light from it hasn't reached us, and never will. This idea, simple in form and elegant in structure, becomes a kind of scaffold for physics itself. It explains why information cannot be transmitted faster than light. It prevents paradoxes where a message arrives before it is sent. It ensures that causes come before effects. And it does so not because there is some grand cosmic referee, but because the very fabric of space-time is stitched together with this rule woven deep inside. This is why physicists love the image of the light cone. It takes something deeply abstract, relativity, causality, the limitation of influence, and turns it into something spatial, something you can draw on paper or picture in your mind. You are the candle, your actions are the light, and the cone is the space through which your effects may echo. Now consider this. The universe itself has a light cone. The Big Bang, if we picture it as a single flash at the beginning of time, casts a cone of expanding influence. And we, sitting here in the present, are within that cone. We are its children. We are inside its story. Everything we observe, every signal we receive, fits within that unfolding, ever-widening reach. In fact, the entire observable universe is bounded by our past light cone. Not because that's where the universe ends, but because that's as far as we can see. Light from anything beyond hasn't had time to reach us. Not yet, maybe not ever. And so, what we see in our telescopes, what we read in starlight and radio waves, is shaped entirely by this cone. Every galaxy, every pulse, every ancient echo is filtered through this invisible boundary. It's the map of what can be known, not just physically, but philosophically. It is the field on which all knowledge plays. That might sound limiting, but it's also deeply beautiful. Because it means that your life, your body, your thoughts, even the quiet moment you're having right now, are part of a vast overlapping network of light cones, a web of influences stretching through time, some stretching from the first moments after the Big Bang, others beginning now from you, radiating outward. Perhaps one day, long after you're gone, some faint ripple of your presence, an idea, a word, a change you caused, will travel outward and brush gently against the edge of someone else's light cone. And they too might feel that touch and not know why. By now, we've grown familiar with the idea of boundaries in the universe, the quiet, invisible limits that shape what's possible and what is not. We've walked gently around the speed of light, like guests at the edge of a sacred grove. We've accepted its rule, not with frustration, but with a sense of awe. But as with all boundaries, the question inevitably arises, what if we could cross it? Let us drift for just a moment into the realm of speculation. In the 1960s, physicists coined the term tachyon, a hypothetical particle that, instead of struggling to reach the speed of light like everything else, is born moving faster than light. It doesn't accelerate past that limit. It lives on the other side of it, forever outside our reach, always travelling too quickly to be caught. Tachyons were never observed. No experiment has found them. They exist only in theory, and even there they carry uncomfortable consequences. But the idea alone is enough to stir the imagination, because if something could move faster than light, it could break causality. Imagine tossing a stone into a still pond. Ripples spread outward. They touch the reeds, startle a bird, leave rings of consequence. But now imagine the ripple appears before the stone touches water. The effect precedes the cause. The splash reaches your ears before the stone leaves your hand. That's what faster than light travel could do. If you could send a message faster than light, someone else, moving at a different speed or standing in a different gravitational field, might receive it before you sent it, and they in turn could reply in such a way that you receive their response before they received your message. Round and round it goes until time, logic, and memory all begin to blur. You could warn yourself not to send the message. You could answer a question you haven't heard yet. You could write a story where the ending causes the beginning. At first, this sounds like a paradox from a bedtime riddle or a playful science fiction plot. Delightfully strange, even whimsical. But if it were real, it would mean that time has no direction, that events no longer follow each other in a meaningful order, that the very concept of before and after begins to disintegrate. Physicists call this a causal violation, and they do not treat it lightly. In the carefully balanced equations of general relativity, space and time are flexible, yes, but not unbounded. Their warps and weavings still obey the principle that cause must come before effect. This is not just a rule of narrative, it is a pillar of how things unfold. Without it, science cannot predict, life cannot choose, and minds which rely on memory and consequence cannot function. Now, to be clear, tachyons have never been observed. There is no credible evidence they exist. In fact, many believe their inclusion in theories is more mathematical artifact than physical possibility. They emerge from certain equations, yes, but often as signs of instability, as if the math is warning us, this is not a place you want to go, and perhaps that's a kindness, because the price of faster than light travel is not just a new technology, it is the undoing of time itself. If particles could cross the light speed boundary, they would blur the edge between past and future. They would tangle timelines, fold cause into effect, and open doors where logic leaks out like air from a cracked window. The very coherence of existence, the gentle sequence of now, then, and next, would begin to unravel. And yet we are drawn to the idea, perhaps because we too live with our own forms of causal dreaming. We remember things out of order. We imagine futures before they happen. We wonder what might have been if a word had been said or left unsaid at just the right moment. Our lives are not purely linear, even if physics insists the universe is. In dreams, the past blends with the present. In grief, we feel echoes of a time before, reaching out to touch us. In love, we act on feelings that ripple far beyond their moment of origin. So maybe it's no surprise that stories of time travel speak to us. Maybe they echo something emotional, even if not physical, a longing to step outside the flow, to correct a mistake, to hold on a little longer. But the universe, it seems, holds the line. Faster than light motion doesn't just defy engineering, it defies the symmetry of time. It creates loops that break everything else. And so, we remain where we are, within our cones, within our tempo, moving steadily forward. Still, the thought lingers like a ghost of curiosity. What if there are domains of reality we cannot touch, not because they're too far, but because they are structured differently? Realms where time flows sideways or loops or folds in on itself, where causality follows different rules or none at all. Science does not deal in final answers. It deals in questions that hold up under scrutiny. Tachyons have not, but they remind us of something valuable, that the laws of the universe are not arbitrary rules we could simply wish away. They are the framework that allows stories to unfold at all. And maybe it's comforting to know that in this vast, spinning cosmos, effects will always follow causes, that no message will arrive before it is sent. That light, with its quiet, steadfast speed, keeps our stories anchored in order. So tonight, as you rest, let your thoughts drift as far as they wish. Wander into what-ifs, into dreams of time folding gently backward, but let them be dreams. The waking world, the one you return to, is safe in its rhythm. And the light that reaches you tonight, it came honestly. It took its time. Picture a soft black sheet stretched tightly across a frame. Now imagine placing a heavy marble in the centre. The sheet sags, pulling inward, forming a curve. If you roll smaller marbles near the heavy one, they no longer follow straight lines. Instead, they spiral, loop, or fall inward, not because they are being pulled directly by the heavy marble, but because the surface itself is curved. This is more than a classroom demonstration. It is a window into one of the most profound shifts in how we understand the universe. Before Einstein, gravity was thought to be a force, an invisible tether pulling objects toward each other across space. Newton's apple fell from the tree because Earth exerted a downward tug. The moon circled Earth because of this mysterious pull. Gravity was an action at a distance, reliable and predictable, but not deeply understood. Then, in 1915, Albert Einstein gave us a new way of seeing. Gravity, he said, isn't a force at all. It's the result of curved space-time. Mass and energy, more broadly, causes space-time to warp. That warping tells matter how to move. Objects don't need to be pulled. They're simply following the straightest path they can. Only now, those straight lines are bent. A planet in orbit around a star is not being yanked like a ball on a string. It's simply falling along a curved path in a curved space. To understand this, we must let go of the idea that space and time are separate. They are not two different fabrics stitched together at the edges. They are one unified thing, space-time. Wherever mass exists, it curves this four-dimensional fabric, not just bending distances, but slowing time itself. This sounds abstract, but its effects are very real. Take time, for instance. A clock on the surface of Earth ticks more slowly than a clock in orbit, not because the mechanisms differ, but because time itself flows differently depending on the strength of gravity. The stronger the gravity, the deeper the object sits in a gravitational well, the slower time moves. This is not poetic exaggeration. We have measured it. Atomic clocks on planes and mountaintops confirm it. The GPS satellites that guide your phone must account for it. If their internal clocks didn't adjust for both speed, special relativity, and gravity, general relativity, your location would drift by kilometers in a single day. You wouldn't find your cafe or your parked car. The directions would simply unravel. But it doesn't stop at clocks and satellites. Light itself bends around massive objects. As it moves through curved space-time, its path is not straight. Because straight is no longer simple. We've seen this happen when light from distant stars bends around galaxies, creating rings and arcs of distorted images in the sky. These phenomena, called gravitational lensing, allow us to peer behind and around cosmic giants, as if the universe were folding itself to give us a better view. And this bending is not a side effect. It is the core truth. In Einstein's vision, everything moves through space-time by following the path that feels the most natural, the geodesic. In flat space-time, that path is a straight line. In curved space-time, it becomes something more elegant, a soft arc, a swirl, a spiral, a curve not drawn by hand but shaped by mass, energy and presence. So now, consider Earth. It orbits the Sun not because it's being tugged like a fish on a line, but because the Sun has created a deep well in the fabric of space-time. Earth is simply falling into that well, sideways, fast enough to keep missing. Over and over, it falls and misses, falling and missing, tracing a near circle year after year. The Moon does the same around Earth. It is not held. It is dancing through curved space. This idea reframes everything. The universe is not a stage with actors moving upon it. The stage itself changes when the actors appear. It bends and swells, slows and ripples. The more massive the actor, the more dramatic the shift. And this gives rise to something even stranger. Space and time are not containers. They are participants. This is why Einstein's general theory of relativity is so revolutionary. It took what seemed like a background, a quiet canvas, and revealed it to be alive with tension and flex, capable of shaping the destiny of stars and the flow of time itself. And it opened doors we are still stepping through. Without general relativity, we wouldn't understand black holes. We wouldn't know how the universe expands. We wouldn't detect gravitational waves or map the dark skeleton of the cosmos. We would still think of gravity as a pull instead of a dance, a rhythm between mass and space and time. So next time you feel yourself standing still, remember this. You are not resting on a static floor. You're pressed gently into a curve. Earth, under your feet, is shaping the flow of time around you. The sun is bending space with its warmth. The galaxy, massive and quiet, is warping space-time so slightly that the light of distant stars arrives just a little bent. We don't float in space. We move through a river of curves. And the way we fall, the way we orbit, the way we age, it's all part of that invisible architecture. Not imposed from outside, but written in the shape of the universe itself. Sleep, then, knowing that you're not separate from the cosmos's design. You're folded gently into its curves. You may think of time as something fixed, a metronome that ticks evenly, day or night, rain or shine. A clock on the wall, or on your wrist, or in your phone. Always moving forward, always at the same rhythm no matter who watches it. But the universe doesn't measure time the way we do. It never did. In truth, time is elastic, and the faster you move, the more it stretches. This is the strange and quiet promise of Einstein's relativity. That motion changes the very fabric of experience, not just where you are, but when you are. The ticking of clocks slows down, the lengths of objects contract, the world becomes subtly reshaped, not by force or distortion, but by the laws that hold space-time together. Let's begin with something curious. Imagine two identical twins. One stays on Earth, the other boards a spaceship and travels at a significant fraction of the speed of light. When the spacefaring twin finally returns, after what felt to them like a short trip, they find their sibling has aged more. Not a glitch, not science fiction. This is the twin paradox, and it is real. Confirmed not with people, but with particles, clocks, and satellites. The paradox isn't truly a paradox. It is simply the consequence of time's rhythm changing based on motion. In special relativity, the faster you go, the more slowly time passes for you compared to someone who remains still. It's called time dilation, and while the effect is tiny at everyday speeds, it becomes pronounced as you approach the speed of light. For a passenger on a fast-moving spaceship, days may pass while years tick by back home. Their heart beats normally, their thoughts feel unchanged, but when they return, the world has changed, the rivers have shifted, the people have aged, the buildings have crumbled, they have travelled not just through space, but into the future. This is not just a theory scribbled in the back of a notebook. We see it in the skies every day. High above Earth, orbiting satellites move fast, about 14,000 kilometers per hour. That's fast enough for time dilation to matter. The clocks on those satellites tick slightly slower than those on the ground. Not enough for you to notice, but enough that, without correction, your GPS would drift. Every location would be off. Over a day, the error would build and build until your phone believed you were somewhere else entirely. We also observe it in particle physics. In Earth's atmosphere, cosmic rays collide with atoms, producing particles called muons. These muons have a very short lifespan, just microseconds. They shouldn't live long enough to reach the ground, but they do. Why? Because from our perspective, their internal clocks are ticking slowly. Time is stretched for them as they travel at near light speeds. They are, in a quiet sense, slipping through time. This stretching of time is mirrored by a companion effect, length contraction. When an object moves quickly, its length in the direction of motion appears to shrink, from the perspective of someone standing still. This doesn't mean the object feels compressed to itself. Inside the spaceship, for example, everything feels normal. But to an outside observer, the ship shortens, flattens slightly by its velocity. Again, this isn't an illusion. It's built into the geometry of space-time. You might imagine time as a piece of fabric gently draped over space. Now, if someone begins to move across that fabric very quickly, their motion pulls the fabric in a new direction. Time and space shift, tilting together. What seems straight to them now looks tilted to others. Every frame of reference carries its own version of straight, its own version of slow, of near, of long. And this is the deep beauty of relativity. It doesn't deny motion or time or space. It simply weaves them together in such a way that every observer, no matter how fast they move, finds that the rules still hold. Light still travels at the same speed, because still precedes effect. The math still balances. But everyone sees a slightly different picture. This flexibility makes the universe fair and fluid and strange. There's no single perspective from which everything looks correct. No privileged clock that tells the true time for all. Instead, the universe tells each traveller, your journey is yours, your rhythm is yours, and as long as you measure carefully, you will never be wrong. It's easy to imagine that all this is limited to astronauts and particle physicists, that down here on Earth, moving slowly and living quietly, we're unaffected. But in truth, we're always moving. Earth spins at over 1,600 kilometers per hour at the equator. It orbits the Sun at nearly 30 kilometers per second. The solar system spirals through the galaxy at hundreds of kilometers per second more. And yet, despite this dance, everything feels still. Because relativity doesn't just change the measurements, it preserves the experience. The laws are flexible but consistent. They bend without breaking. And so you walk through your day, unaware that your watch ticks at a rhythm different from someone on a mountaintop, or in a jet, or in orbit. Unaware that every moment is shaped by motion, your motion, Earth's motion, the very motion of the galaxy. Time is not universal, but it is coherent. You're not lost in a swirl. You're grounded in your own frame. Perhaps this gives time a softness it didn't have before. Not a harsh metronome, but a gentle pulse, changing with motion, stretching with gravity, beating at slightly different tempos in every corner of the cosmos. And so, as you lie still tonight, know that your stillness is only relative. The atoms in your body jitter with quantum motion. The bed beneath you spins with the earth dances through space, and your clock, your heart, your dreams, they tick at just one of infinite possible rhythms, but it is yours, and the universe, vast and curious, makes room for them all. If you step outside on a clear night and look up, the stars seem still. The sky appears eternal, fixed, silent. But this is a mirage born of short lifespans and limited senses. In truth, the universe is not only moving, it is stretching. Not slowly, not gently, but with a quiet ferocity that escapes our perception. Space itself is growing, not like a balloon inflating from a single point, but more like bread rising in the oven. Every raisin moving away from every other, not because it is flying, but because the dough between them is swelling. This is the expansion of the universe, and it carries within it one of the strangest and most beautiful paradoxes in cosmology. Galaxies are receding from us faster than the speed of light, and yet no rule has been broken. To understand this, we must remember that the speed of light is the universal speed limit, yes, but only for things moving through space. The speed limit does not apply to the expansion of space itself. Let's return to the image of the dough. Imagine placing raisins in rising bread. As the dough expands, the raisins move farther apart, not because they're crawling through the bread, but because the bread between them is growing. From the perspective of any one raisin, All the others are receding, and the ones farther away appear to recede faster. Now replace the raisins with galaxies, and the dough with the fabric of space-time itself. This is not metaphorical. It is how cosmological expansion actually behaves. In 1929, Edwin Hubble discovered that distant galaxies were redshifted. Their light stretched toward a longer, redder wavelengths. This was the first clue that the universe wasn't static. It was growing. Not only that, it was growing uniformly. Every galaxy was drifting away from every other, not because of an explosion, but because the stage upon which they all sat was stretching underneath them. This discovery overturned a core assumption that the universe was eternal and unchanging. And it introduced a new way of thinking, that there is no center of the universe's expansion, no privileged place where the stretching begins. The expansion is not into something, it is the unfolding of space itself. But here is where things get stranger. As galaxies recede, the more distant they are, the faster they appear to move away. Eventually, their recession speed surpasses the speed of light, not because they are breaking the speed limit, but because the space between us and them is expanding faster than light can traverse it. That means some galaxies are already beyond our cosmic horizon. Light emitted by them now will never reach us. Not in a year, or a million years, or 10 billion. They are, for all intents and purposes, cut off. Not because they disappeared, but because the space between us is growing faster than light can bridge the gap. And yet, we can still see some of them, not as they are now, but as they were. The light they emitted long ago before they crossed the horizon is still on its way to us. It is still travelling through the quiet dark, stretching as it comes, becoming fainter and redder. Eventually the light becomes so stretched that it fades into invisibility, a silent goodbye from a galaxy that still exists, but no longer speaks our language of light. This is why the observable universe is not the entire universe. It is simply the region from which light has had time to reach us. It is bounded not by walls, but by time. A soft edge made not of matter, but of delay. It is the shell of knowability, wrapped around us like a bubble of perception. Outside it lies the unknown, unreachable, silent, but still part of the whole. Now here's where the question arises. Does this expansion violate relativity? Number. Because relativity's speed limit applies to local motion. Nothing can move through space faster than light, but space itself can, and does, expand at any rate. The laws remain unbroken. The equations hold. The stretching of the fabric respects its own strange geometry. It's as if the stage itself is moving beneath the actors, and no matter how fast they try to run, the stage pulls away faster. The players remain within the rules, but the rules themselves can drift. This is also where dark energy enters the story. Observations in the late 1990s revealed something unexpected. Not only is the universe expanding, but the rate of expansion is accelerating. Something is pushing space apart faster and faster, defying the pull of gravity. This unseen influence was named dark energy, not because we understand it, but because we don't. We know only this. It exists, it is vast, and it dominates the dynamics of the cosmos. It means that galaxies currently within our horizon may eventually slip beyond it. Their light will cease to reach us. The night sky will grow darker. The cosmos will become lonelier, not because the universe is shrinking, but because our window into it is. And yet, there is something deeply poetic in this fading. The redshift of light, the vanishing of galaxies, the slow hush of a wider world. These are not signs of loss, but reminders of how far light can travel, how patiently it journeys, how deeply stitched into the structure of time that journey becomes. When you look at a distant galaxy through a telescope, you are not seeing it as it is. You're seeing it as it was, millions sometimes billions of years ago. That light has stretched, bent, been filtered through gravity and dust and time, and yet it arrived. You are its landing point, its final resting place. So as the universe expands and more of it slips beyond the reach of sight, remember that we are still held within a bubble of light, a fading echo of beginnings, a moving edge of perception, and beyond that edge, only silence, for now. Somewhere out there, among the drifting stars and scattered galaxies, there are places where the universe folds in on itself, not with noise or violence, but with silence so deep it traps even light. These are black holes, regions where space-time curves so sharply that escape becomes impossible, not because a wall has been built, but because the very paths that lead outward have turned inward. We often imagine black holes as monsters, cosmic vacuums sucking everything into their darkness. But they are not hungry or violent. They do not pull. They simply curve space and time to such an extreme that the direction we think of as away no longer exists. At the heart of every black hole lies a singularity, a point of infinite density, where the laws of physics, as we currently understand them, cease to function, not because they are suspended or violated, but because they are stretched beyond meaning. The equations we trust begin to produce infinities, numbers without end, curvatures without limit. In those places, our understanding falters, but the singularity is hidden, shielded by a boundary called the event horizon. This is the edge of no return. It is not made of matter. You could pass through it without noticing. No bump, no flash, no warning. But once crossed, the journey can no longer be reversed. Light emitted just inside the horizon will never escape. Time flows inward. Space contracts toward the center. The coordinates of the universe rearrange themselves so that all paths, all timelines, lead only deeper. From the outside, something strange happens. If you watched a spacecraft fall toward a black hole, you would never quite see it cross the event horizon. Instead, it would appear to slow down, redshift, and dim. Its signals would stretch, its time would dilate, until finally it would freeze, hovering ghost-like at the edge, forever approaching, never quite vanishing. From your perspective, time at the horizon slows to a crawl. But for the falling astronaut, the story is different. Their experience continues. They feel the passage of time. They move forward, inexorably, past the horizon and toward the singularity, all while the universe outside fades into a cold blur. Communication becomes impossible, not because the distance is too far, but because the light they emit can no longer reach the outside world. They are in every way causally disconnected. Time itself behaves strangely here. At the horizon, time doesn't just slow, it seems to stop, at least to a distant observer. Clocks freeze, processes halt. But this illusion is born from distance and curvature. In the astronaut's own frame, time ticks normally. The strange difference is a result of gravitational time dilation, a deepening of Einstein's insight into how gravity bends not only space, but the very rhythm of time. This leads to one of the most poetic truths in all of physics. At the edge of a black hole, time and space exchange roles. Inside the event horizon, moving forward in space becomes like moving forward in time. It is no longer a choice, no longer a direction you can change. It becomes destiny. The singularity is not just a place you fall toward, it is a moment in your future. You cannot pause or turn or climb back out. To fall inward is to move forward in time. And so black holes are not just spatial traps. They are temporal one-way doors, portals through which time only flows inward. For the outside universe, they mark boundaries where information disappears, where light ends, where certainty fades. This has puzzled physicists for decades. Because if information is lost inside a black hole, What happens to the laws of quantum mechanics, which insist that information must always be preserved? Does the black hole store that information somehow, encoded in its surface? Does it evaporate slowly, releasing secrets in particles called Hawking radiation? Or does the information vanish forever, leaving the universe subtly incomplete? This is called the black hole information paradox, and we do not yet know the answer. What we do know is that black holes are not merely destructive. They shape galaxies. They anchor the hearts of cosmic structures. They may play a role in how stars form, how matter collects, and even how time itself is woven. We also know that black holes can spin. They can merge. They can ripple the fabric of space-time and send gravitational waves rippling across the cosmos. We've detected these waves, faint shivers that pass through Earth, caused by the collision of black holes billions of years ago. These waves carry information. They whisper of spirals, of mergers, of the deepest dances in the universe. And yet, for all their power, black holes are silent. They do not shine. They do not radiate. They speak only through the light they hide and the gravity they shape. They are not villains. They are part of the architecture of reality, necessary, mysterious, and strangely peaceful. To sit at the edge of a black hole, even in imagination, is to reflect on the limits of what we can know. It is to consider a horizon not only of light, but of meaning. A place where time folds inward, where space gives up its reach, and where the universe draws a soft curtain. Perhaps, in some far future, we will learn how to read the surface of a black hole like a book. Perhaps we will understand how it stores memory, how it sings in radiation, how it balances the ledger of energy and entropy. But until then, black holes remain the universe's deepest sighs, its quiet retreats into silence. And if time ever has a final resting place, it may be there, on the edge of an event horizon, watching stars fade. Close your eyes for a moment and imagine a glass slipping from a kitchen counter. You hear the crash, the scatter of shards across tile. Water splashes outward, then settles into silence. It's a moment of small disaster, one we've all witnessed. But now imagine the reverse. Broken pieces pulling themselves inward, water droplets rising, coalescing, forming a whole glass that leaps back onto the counter. It's not just improbable, it feels wrong. Not because physics forbids it, but because time doesn't work that way. Why? Why does time seem to have a preferred direction? Always forward, never back. This is the question at the heart of entropy. And while it's easy to think of time as something clocks measure or calendars track, the real story runs deeper. Time's direction, its arrow as physicists call it, emerges not from how we count it, but from how change unfolds in the universe. And central to that change is a single, powerful concept: entropy. Entropy is often misunderstood. People equate it with chaos, or mess, or randomness. But really, entropy is a measure of how many different ways a system can be arranged. A neat row of playing cards has low entropy, only one configuration. A shuffled deck has high entropy, many possible states. The more disorder, the more entropy. Here's the strange part. Most of the fundamental laws of physics don't care whether time moves forward or backward. The equations that describe how planets move, how particles bounce, how fields interact, they all work just as well in reverse. If you filmed two particles colliding and played it backward, the math would still be valid. But the second law of thermodynamics stands apart. It tells us that in any closed system, entropy will tend to increase. Things will become more disordered, not less. Energy will spread out. Heat will flow from hot to cold. A broken glass won't unbreak. A spilled drink won't return to the cup. The past is fixed because it was more ordered. The future is open because it is more probable. This, quietly and without exception, is what gives time its forward march. It's not a tick or a tock, it's the statistical unfolding of possibility. There are more disordered states than ordered ones, and so, as the universe evolves, it naturally flows from low entropy to high, the same way a drop of dye disperses through water, not because it wants to, but because there are more ways for it to be mixed than unmixed. This is the arrow of time. It's not dictated by the rotation of planets or the swinging of pendulums. It's written into the very fabric of statistical mechanics. The universe began in a state of astonishing order, smooth, hot, dense, with energy packed into a neat, uniform shape. And from that improbable beginning, it has been unravelling ever since. Stars ignite, burn, and fade. Mountains erode, heat dissipates, and time quietly follows the path of least resistance. If entropy were reversed, time would reverse, but we never see that happen, not because it's physically impossible in a strict sense, but because it's statistically so unlikely that it may as well be. You could wait for the molecules in your room to cluster in one corner and create a temperature spike, but you'd wait longer than the lifetime of the universe. This arrow doesn't just apply to broken things or cold coffee. It applies to everything that remembers. Memory too is a child of entropy. You remember the past because it left a trace. Light entered your eyes, impressions formed in your brain, neurons changed their state. That act of memory creation increased entropy somewhere else. To record an event is to organise part of the universe, and organisation has a cost. Energy must be used, heat must be released, order must be maintained. So the reason we remember the past but not the future is not just psychological, it's thermodynamic. The future hasn't left its trace yet, the past has. You're standing in a current that flows only one way, not because of habit, but because of structure. Even dreaming is part of this. To imagine, to simulate, to construct ideas out of ordered thoughts. It all consumes energy, and in doing so, contributes to entropy. Every breath you take, every blink, every thought is a small act of order in a universe that is slowly letting go of its precision. And yet, this unfolding is not sad. It is not decay for the sake of decay. It is transformation, from order to possibility, from simplicity to richness, from silence to story. Time flows forward not because someone wound the clock that way, but because the universe prefers the paths with the most ways to unfold. And so, a broken cup, a faded photograph, a sunset, all are part of the same river. They drift downstream because that is the only way the river flows. When physicists say entropy increases, they are not describing ruin. They are describing the widening of the story. The past is a narrow gate. The future is a vast field, and we walk through it step by step, breath by breath, memory by memory. Entropy is what gives us that walk, and the arrow of time, it's the direction in which we dream. If entropy is the quiet rhythm that drives time forward, then life is the melody played against it, temporary, delicate, and improbably ordered. You, sitting or lying still, listening now, are a bundle of patterns held together by energy, by structure, by a steady resistance to the unravelling all around you. And that resistance, as elegant as it is, comes at a cost. Your body is not a closed system. You're alive precisely because you exchange energy with your surroundings. You eat, breathe, metabolize, think, all actions that draw in order, convert it, and push disorder back into the world. In thermodynamic terms, you maintain low internal entropy by constantly exporting entropy into the environment. You are, in the language of physics, an open system, a temporary pocket of order sustained by the flow of energy. Every breath you take brings in oxygen, which your cells use to burn fuel and release usable energy. That energy allows muscles to move, neurons to fire, organs to coordinate. But each of those acts, moving a hand, beating a heart, remembering a name, releases heat. It radiates disorganized energy outward, and that heat, that disorder, is the price of keeping your house in order. Take memory, for example. It might feel immaterial, an idea, a dream, a flicker behind the eyes. But memory is deeply physical. It takes work to remember. In your brain, remembering is not a passive state. It's a thermodynamic process. Neurons change their connections, synapses strengthen, patterns of activity form and reform like ripples across a pond. All of that requires energy, and all of that produces entropy elsewhere. To store a memory is to build structure, and structure must be paid for. The more intricate the memory, the more entropy you must offload into your surroundings. The act of remembering your mother's voice, or a warm afternoon, or the shape of a cat's shadow in the sun, it's beautiful, and it's thermodynamically expensive. In that sense, your brain is a kind of entropy engine, a machine for generating ordered thoughts while shedding heat into the world. Not wastefully, not destructively, but inevitably. Even your dreams, those strange nighttime landscapes where logic loosens, are built upon patterns of neural activity, coordinated cycles of memory and metaphor, flickering like lightning through a forest. That dance too burns fuel. Your dreaming mind is not idle. It is working through the day's data, recombining fragments, searching for meaning, and in doing so, it leaves a thermodynamic footprint. What's remarkable is not that life fights entropy, it's that life dances with it. Organisms don't violate the second law of thermodynamics. Quite the opposite, they are expressions of it. Life exists only because energy flows from high concentrations to low, from sunlight to sugar, from food to heat. Life is the pattern that emerges along that flow, not against it. When you eat a piece of bread or sip warm tea, you're not just taking in sustenance, you're taking in order, organized energy and chemical bonds. Your body digests that order, uses it to maintain internal balance, and radiates the leftover entropy into the air as heat. It's the same process on every scale, from bacteria to galaxies. Structure is fleeting, and it's preserved only by making the rest of the universe a little more disordered. Even love has a thermodynamic signature. To care for someone, to cook them a meal, to write them a letter, to build a life together requires work, emotional effort, physical labour, cognitive load. That work too releases heat. Intimacy is not free, it must be paid for in energy, but the beauty is in the trade. You create temporary moments of order, of safety, of shared structure, and in return you let a little warmth drift out into the air. You're a torch burning cleanly against the dark, and entropy is not your enemy. It is your companion, the backdrop that gives your warmth its meaning. This idea doesn't make life less sacred, it makes it more so. Because when you realize that each moment of clarity, each breath of balance, each burst of laughter requires energy, not just in metaphor but in physics, it becomes easier to see how precious those moments are. You're unlikely. You're a configuration of atoms that has resisted entropy long enough to think, to wonder, to feel the deep hum of existence, and that resistance is temporary. One day, the energy that flows through you will stop organizing itself. Your memories will dissolve, not into nothing, but into randomness, like pages from a book torn out and scattered. The warmth will leave your body, joining the air, the earth, the stars. You will return to the background hum. And yet, while you lived, you were a kind of flame, brief, bright, and real. Life is not the opposite of entropy. It is the bloom that entropy allows. Without disorder increasing elsewhere, there would be no way to maintain islands of order here. Without heat flowing outward, there would be no thoughts flowing inward. The rise of entropy makes possible the rise of everything you hold dear: breath, memory, meaning. So when you rest tonight, know that the stillness you feel is not the end of motion. Your cells are still whispering, your body still radiating, your brain still glowing. Entropy moves through you as gently as time, and in every quiet moment you are paying the small, noble price of being alive. Picture the early universe, not long after the Big Bang. It was hot, dense, bright, and remarkably uniform. Energy was spread evenly. Particles were tightly packed. There was no structure, no stars, no galaxies, no shadows between them. And yet, strangely, this simplicity, this high-energy sameness, was a state of low entropy. It may seem backward. Shouldn't a uniform cloud be more disordered than a star-filled sky? But in physics, disorder isn't measured by what looks complex. It's measured by the number of ways a system can be arranged while still appearing the same. A smooth, featureless gas has fewer possible arrangements than a universe filled with stars and planets and people. So the early universe, despite its heat and density, had remarkably low entropy, a kind of cosmic innocence, a tightly wound spring ready to unwind. And unwind it did. Over billions of years, gravity gathered matter into clumps. Those clumps ignited, stars were born, galaxies spun into shape. Some stars lived brief, brilliant lives before collapsing or exploding. Others endured warming planets. The expansion of space cooled the cosmic temperature. Complexity emerged, delicate, temporary, and costly. Entropy was rising. That's the direction the universe has always moved. Not from chaos to order, but from simple order to distributed richness, and eventually to quiet dissolution. Every time a star shines, it burns fuel, converting concentrated energy into light and heat. That light travels outward, spreading entropy into the cold. When a star dies, it may collapse into a black hole or drift into a faint white dwarf, cooling over trillions of years. Galaxies that once teemed with stars now carry the ghosts of suns, dimming like embers in a darkening hearth. This is not sudden or violent. It's the slow breath of time exhaling. Eventually, far, far into the future, most stars will burn out. No new ones will be born. Black holes will dominate. They too will fade, slowly evaporating through Hawking radiation, releasing whispers of energy back into the void. One by one, even the deepest wells of gravity will empty. This is what physicists call the heat death of the universe, a state of maximum entropy. No usable energy, no gradients, no sparks, no stories. A vast sea of cold particles drifting in ever-expanding space, with no difference between one place and another. Not a fiery end, but a quiet one. Not an explosion, but a dissolution. The universe stretched so thin that nothing happens anymore. But this is not a tragedy. It is not failure point. It is the natural conclusion of a story told through entropy, a journey from a tightly wound beginning to a fully unspooled future, and we, brief glowing clusters of order, are part of that story. In the grand arc of the universe, we are temporary islands of low entropy, using energy to maintain form, to think, to build, to love. We are the eddies in the current, where complexity briefly blooms before joining the flow again. Every heartbeat, every sunrise, every laugh is an act of local order, and every one of them adds a little warmth to the expanding night. There's a kind of quiet comfort in this. Entropy does not erase meaning. It is the stage upon which meaning plays out. Without it, time would not flow. There would be no change, no memory, no evolution, no life. The stars that warm our planet, the food that nourishes us, the thoughts we share. They all exist because energy moves from usable to spent, from concentrated to diffuse. We are shaped by this river, and even when our moment passes, the river continues. Our atoms will scatter, our heat will rise, our footprints will blur, but the path we walked will remain part of the pattern, like ripples on a pond spreading outward. So when we speak of the end of the universe, We're not mourning a life cut short. We're observing a life fully lived. A cosmos that began in silence, learned to shine, and eventually returns to stillness, not because it failed, but because it completed its arc. And if you find that idea comforting, you're not alone. Many physicists and philosophers see the rise of entropy not as a loss, but as a canvas, one that allows fleeting shapes to form, just as a blank sky allows stars to shine, just as silence allows music to be heard. Entropy is what gives the universe texture, time, memory, beauty. And in this way, perhaps the universe is telling a story, not in words but in gradients, in temperature, in the slow softening of form. From bright to dim, from hot to cool, from tight to scattered, a story written in the language of change. And though the final chapter may be quiet, the pages that came before it are filled with light, with warmth, with motion, and with you. Imagine for a moment that you are light, not surrounded by light, not holding it, not bathing in it, but being it. A photon, a single particle, weightless, ageless, moving through space at the fastest possible speed the universe allows. You're born not from flesh or breath, but from motion. An electron shifts in an atom, and you emerge, not in pain or fanfare, but in silence, as a shimmer of possibility made real. You travel at 299,792,458 meters per second, the speed of a light, the cosmic constant. No matter who observes you, standing still, racing alongside, turning upside down, you always move at that same speed, no more, no less. But the strangest part is not how fast you go, it's what that speed means. According to Einstein's special relativity, the closer an object gets to the speed of light, the more time slows down for it. A spaceship at near light speed will experience fewer seconds than an observer left behind. But for a photon, for you, this effect becomes complete. You experience no time at all. Your internal clock never ticks. From your perspective, the moment you're emitted and the moment you're absorbed are the same moment. A single event stretched across space, but not across time. From a human view, you might have left a distant galaxy 5 billion years ago. You travelled through voids, past stars, bent slightly by gravity, stretched gently by expansion, finally arriving tonight in someone's eye. But to you, none of that happened. There was no journey, no waiting, just departure and arrival, fused into a single eternal now. In that sense, photons are not merely fast, they are timeless. They are messengers that do not age, they do not tire, they do not slow. They carry energy and information across unimaginable distances, and yet they remain suspended between 2 points in space-time, like beads on a thread pulled taut. This is not metaphor, it's what the equations tell us. At light speed, time does not pass. Length contracts. The distance between source and destination shrinks to nothing. For the photon, there is no space to cross, just a handshake between two events. What does that feel like? We cannot know. We are made of mass. We are anchored to time. Even in our dreams, we age. Even in stillness, our molecules move, our clocks tick, our neurons fire. Time is the rhythm of our existence. But for a photon, there is no rhythm, only arrival. Perhaps this is why light feels so different from everything else. It doesn't behave like rocks or water or wind. It doesn't linger. It doesn't decay. It shows us the world, but never leaves a mark of its own. It illuminates, reflects, bends, but never stops. You cannot trap light in a bottle and keep it. It moves, or it dies. And yet, without photons, there would be no vision, no colour, no warmth, no communication. Every image you've ever seen, every face, every sunrise, every page, every sky, is composed of photons entering your eyes. Some may have bounced off objects a few feet away. Some may have left their stars before Earth even formed. All of them carry a whisper from their origin, and all of them, in their silent journey, experience no delay. In a way, this makes photons the perfect time travelers, not because they move through time, but because they bypass it entirely. They connect now to then with no in-between. They allow us to see the past not as memory or imagination, but as something physically present, carried, delivered. The light you see from Sirius left 8 years ago. The glow from the Andromeda Galaxy departed 2.5 million years ago. Some photons reaching our telescopes tonight began their journeys before humans walked the Earth. Before Earth itself had an atmosphere, and still to the photon, it is all the same moment. They are threads in the fabric stitching together the distant and the present. And so, when you look at a candle or a star or even the faint glow of your phone screen, you are not just seeing brightness. You are witnessing an arrival, a journey concluded in silence. A packet of energy, ancient or new, making contact with your eye, becoming part of your story. What does it mean to be timeless? To never wait, to never change, to exist only in the connection between 2 points? It is hard to say. We are creatures of sequence, of heartbeat, of breath. But perhaps it's enough to simply know that such things exist, that there are entities in this universe that cross the cosmos without experiencing time, that the light touching your face this very moment may have left its source long before you were born, and yet to itself was always already here. You live in a world stitched together by such arrivals. You see by catching ghosts that never aged. You warm yourself with rays that have never rested. And though you may measure light in nanometers, in lumens, in joules, it is also something more, a messenger that brings the past into presence, that connects one atom's shiver to your awareness, that, without ever experiencing time, illuminates all of it. So tonight, as you rest, think of the light around you, not as glare or glow or wave, but as a stream of visitors. Each one has come a long way to arrive here, and though they know no journey, they offer you one, a chance to see, to remember, to wonder. They are the oldest travellers in the universe, and they have come here, to you, with stories they cannot tell, but that you, quietly and gently, can feel. Every time you open your eyes, you're not just seeing, you are time travelling. Not in the dramatic, cinematic way of stepping into machines and blinking into distant centuries, but in a much softer, quieter, and far more constant way. Because every beam of light that reaches you carries not the present, but the past. It brings with it a memory, not your own, but the universe's. Light travels fast, but not instantaneously. It moves at a fixed speed, just under 300,000 kilometers per second. That's fast enough to circle Earth more than 7 times in a single second. But even at that astonishing pace, it takes time to get from there to here, and in that time, the world changes. The light bouncing off your hand takes a few nanoseconds to reach your eye. That's so short you'll never notice. But already it's not now. The moon, you see it as it was 1.3 seconds ago. The sun, 8 minutes in the past, and the nearest star beyond that, Proxima Centauri, over 4 years ago. The farther away something is, the further into the past you must look to see it. Distance is time, stretched across space. This becomes especially wondrous when you look up at the night sky. Those stars, tiny, flickering dots, each a world unto itself, are not what they appear. Some may no longer exist. Some may have already exploded, gone cold, moved on. But the light they cast long ago is only just now arriving. You are receiving the ancient echo of a moment that no longer exists. In that way, every act of seeing is also remembering. Your eyes are not just organs of sight. They're receivers of old messages. You're surrounded by ghosts of the universe's earlier self, all quietly arriving, photon by photon, telling you what once was. The deeper we look, the farther back we go. With telescopes, we can peer millions, even billions, of years into the past. Light from distant galaxies bent by gravity, stretched by expanding space, reaches our senses and paints pictures of an earlier universe. We see galaxies not as they are now, but as they once were. Young, raw, tangled in their birth. And then beyond even that, there is a kind of wall, a boundary not of matter, but of time itself. Roughly 13.8 billion years ago, the universe was born in a hot, dense state, the Big Bang. At first, it was too opaque for light to move freely. Photons collided constantly with charged particles, bouncing, scattering, never travelling far. It wasn't until about 380,000 years later that the universe cooled enough for atoms to form. Suddenly, light could travel freely, unchained, unscattered. And that first light is still with us. It's called the cosmic microwave background, or CMB. It's not bright or dramatic. In fact, it's incredibly faint. A whisper of warmth that pervades all of space. But it's there in every direction, and it is the oldest light we can see. A baby picture of the universe. Not a snapshot of galaxies or stars, but of hot, glowing plasma, just before everything began to take shape. We've mapped it. We've studied it. We've listened to its hum. It tells us that the early universe was remarkably uniform, with tiny fluctuations, tiny ripples, that would later grow into galaxies, clusters, and everything we now see. The CMB is like a fossil made of light, not just a trace of what once was, but a record of how everything began. So when you look at the sky, you're not just seeing stars, you're seeing layers of history, stacked not in books but in light waves. The closer stars speak of recent centuries, the farther ones whisper of ancient epochs, and the faint microwave glow, humming gently in the background of it all, carries the soft heartbeat of the beginning itself. There's something comforting in that even after billions of years, photons from that first moment are still out there, still travelling, still telling the story. Not because they were sent with purpose, but because that is their nature. To move, to carry, to connect. We build telescopes not just to see, but to remember, to listen to what light has to say. And in doing so, we realise that we are not observers standing apart from the universe. We are part of the message. Our eyes, our minds, our instruments are just the latest surfaces upon which light lands. For every image we capture, every signal we decode, we are completing a journey that began long before we were born. Photons are not only travellers, they are threads, stitching the now to the before. They let us hold hands with moments we never lived. They allow galaxies from the other side of time to whisper into our telescopes. They give us the sky, not as it is, but as it once was, and always will be, in the form of travelling light. So next time you look at a star, any star, remember this. The light touching your eyes tonight may have left its source before your ancestors walked the earth. It may have passed unnoticed through cold clouds, through drifting dust, through cosmic silence. And yet, it made it. It arrived. It finishes its journey with you. You are the final surface, the last stop, the receiver of time carried across space. And that is not just beautiful. It is humbling. Because in that small act of seeing, you become part of the universe's memory. When you step outside on a warm afternoon and feel the sunlight on your skin, what you're really feeling is history. Photons that left the surface of the sun 8 minutes ago, after spending thousands of years bouncing inside its core, finally reaching Earth, finally reaching you. Each one a tiny, tireless traveller, born in nuclear fire, now transformed into warmth, into glow, into life. Light, for all its quiet presence, is the oldest teacher of life on Earth. It arrived before us, long before, shaping the landscape and laying the blueprint for every leaf, every eye, every step we've taken since. The first life forms on Earth didn't crawl or swim. They absorbed. Tiny organisms floating in ancient seas learned to harvest sunlight. They evolved a kind of molecular mirror, chlorophyll. This humble pigment opened a gateway. It turned light into food, into energy, into growth. And from that small green beginning came all the forests, the flowers, the fruit, and eventually you. Photosynthesis wasn't just an adaptation. It was a turning point. Through it, sunlight became sugar, energy became memory. The sun's brightness embedded itself in living matter, and with that came oxygen, breath, movement, complexity. Light didn't just nourish life, it shaped it. Evolution followed its cues. Creatures emerged with pigments tuned to specific wavelengths so they could sense it, follow it, hide from it, or hunt by it. Eyes developed, not all at once, but step by careful step. Simple patches of light-sensitive skin became lenses. Lenses became retinas. And somewhere along that branching tree, a creature first looked up and saw a star, and then another, and then began to wonder. You're part of that lineage. Your eyes, with their rods and cones and shimmering tears, are tuned to the very narrow sliver of light called visible. Just a tiny band on the electromagnetic spectrum, but it's the band the sun shines in best. Evolution didn't pick that range randomly. It was chosen by history, by what was available, by what warmed our seas and lit our days. In that way, your vision is not merely a trait, it is a form of remembrance. Your eyes carry within them the memory of ancient tides, of chlorophyll's choices, of light bouncing through water and air. And when you dream in images, when you imagine brightness or colour, you're still shaping and reshaping light in your mind. Even fire, the flickering warmth of a campfire or the glow of a candle, is a kind of light reborn. It releases stored sunlight from wood or wax, releasing photons that once danced in leaves, in sugar, in the breath of trees. When you warm your hands by a flame, you're holding a piece of summer that never died, only changed shape. You can think of life itself as a slow unfolding of light. Sunlight enters a leaf. The leaf turns it into chemical bonds. A fruit grows and you eat it. Your body digests it, turning bonds into motion. You walk, speak, remember. You think, and in thinking you light up neural pathways. Electrical impulses, brief, bright flickers, carry your thoughts from cell to cell. Your very consciousness is shaped by the flow of energy, light that has been structured, slowed, remembered. That is one way to understand life, not as a thing separate from physics, but as a process built atop it. The laws that govern photons also govern your heartbeat. The same principles that let light stream across space allow your mind to form memories. Thought is not magic, it is movement, patterned, meaningful movement, like sunlight filtered through stained glass. And so the physics of light is not just abstract, it is intimate. It is present in your cells, in your breath, in the heat of your coffee cup, in the flicker of your computer screen. It is the reason you can read this sentence, and the reason the sun rises, and the reason leaves turn gold in the fall. Light is not passive. It is active energy, always transforming, always shaping, and it carries us. It carried us from the beginning, when the first cells shimmered with sunlight. It carried us through ages of vision and warmth and motion, and it still carries us now, every day, from morning through evening, from breath to thought to memory. You're not just made of atoms. You're made of energy given structure, light that chose, for a little while, to hold a shape. And even after your body has spent its warmth, after your thoughts have quieted, that energy does not vanish. It returns, it spreads, it joins the endless flow, like a spark that once was a flame, now drifting gently through the dark. So next time you see sunlight on water, or a shaft of light through a window, or the glow of fireflies in the dusk know this: the light that carried life to Earth is still here. It is still speaking, still warming, still shaping. And in the quiet geometry of its travel, it remembers you. There's a way we often talk about entropy as if it were the villain of the universe, the slow thief, the quiet eraser, the silent force that makes all things fall apart. And yes, entropy is the reason why candles melt, why snowmen disappear, why warm coffee cools, why all stories end. But to see it only as loss is to miss the music. Entropy is not destruction, it is transformation. Think of a burning candle. It doesn't just vanish. As it glows, it gives heat to the room, light to the eyes, comfort to the hands that hover near it. Its wax melts, its molecules rearrange, and in that rearrangement, something beautiful happens. It's not that the candle is dying, it's that it's becoming something else. Energy released, shared, spread. Or think of a breath on a winter day. The warmth leaves your body, becomes mist, then disperses into the air. It does not disappear. It joins the world, and in doing so, it tells the story of motion, of contact, of change. Entropy is the principle behind this unfolding. It is the reason why energy moves from concentrated to diffuse, from useful to spent, from flame to ash. But within that process, there is structure. There is meaning. The universe doesn't just fall apart, it evolves. When a star burns, it is not only losing fuel, it is forging elements, carbon, oxygen, iron, the very atoms that later form planets, oceans and living cells. Your body contains calcium from old suns. The iron in your blood was forged in stellar fire. What appears as loss from one perspective is creation from another. Entropy increases, yes, but the shapes it takes along the way are rich and temporary and filled with pattern. Like waves in the sea, they rise, crest and fall, each one unique and each one part of the larger flow. The human mind is a master of finding order in that flow. You're not just a creature obeying thermodynamic laws. You're a being that remembers, imagines, reflects. Your brain runs on entropy, transforming energy into thought, organizing signals into stories. And in doing so, it creates something that didn't exist before: understanding. It's easy to think that the universe is winding down, that because entropy rises, everything must end in stillness. But perhaps that's not an end. Perhaps that stillness is the final verse of a long, slow song, a moment of quiet after all the verses have been sung. If entropy were a villain, the universe would be chaotic from the start. But instead, we had structure. We had stars and galaxies, weather and life. We had the conditions for music, for firelight, for laughter in dark rooms. Entropy made those possible too. It's not a force of malice. It's a measure of possibility. When energy is concentrated, it has potential. When it spreads, that potential is spent, but not erased. It becomes background warmth. It becomes the glow that lingers after the flame. You feel this in your own life, don't you? The way memories soften around the edges, becoming more like feelings than facts. The way a song, once loud, echoes longer in your heart than in the room. The way the warmth of a hug lingers on your sweater long after the person has gone. Entropy isn't stealing those things, it's changing their form. And sometimes that form is gentler, quieter, no less real. This is why entropy, though often framed as decay, can be viewed as something more lyrical. It gives time direction, it gives change texture, it gives life its curve. Every system seeks equilibrium, not to disappear, but to share, to let energy flow freely. A hot pan cooling is not dying, it is joining the room, becoming part of the air. The moment you step into a sunlit space, you feel this, the transfer, the mix, the balance seeking itself. Even black holes, those titans of mystery and silence, obey entropy. They absorb matter, light, time, and in doing so they gain entropy too. Eventually even they will evaporate, not in fire, but in the slow radiation of their heat, pixel by pixel, until nothing remains but the memory of what once fell inward. And yet, in the time between that beginning and that final fade, there is so much. There are stars and children and questions and whales and wheat fields. There are campfires and cold hands, the taste of salt, the arc of comets, the way your heartbeat stutters when you hear someone call your name. Entropy allows all of this to happen, because without entropy there would be no flow of energy, no spark to light the flame, no breath to carry the word, no warmth to stir the cell. Without it, the universe would be frozen in symmetry, perfect, unchanging, and lifeless. We do not live in a tragic universe. We live in one where every fading moment glows a little before it goes. Entropy isn't the end. It's the price of motion, the cost of having stories to tell. It's the song beneath all other songs, the hum that says something once was, something now is, and something new will come. And when you lie down tonight, when your breath slows and the day becomes memory, remember, you are part of that song. Your warmth, your motion, your thoughts, they are verses in the great unfolding. They are not being lost, they are being sung. And when morning comes, the universe will not have paused, only shifted its light. The same currents that rocked you to sleep will still be flowing, unseen yet steady, weaving the quiet pulse of existence through every leaf, every atom, every breath. The dawn will not break suddenly, it will unfold like the slow turning of a cosmic page, and you, small as a thought and vast as awareness itself, will continue to be part of that unfolding. The sunlight that finds your eyelids will be ancient, its journey begun before your first heartbeat, before your name, before the oceans had their current shapes. It will have crossed the silent vacuum, brushed against dust and gravity, and the faint echoes of forgotten stars just to arrive here, at this gentle intersection of time and you will rise, not as someone new, but as something continuous, a ripple in a longer rhythm, a temporary arrangement of stardust still learning how to glow. The heartbeat in your chest will echo the slow, patient pulse of galaxies. The air you draw in will have passed through countless lives before yours, through forests and lungs and oceans, returning again, always changed, always the same. This is what it means to belong to the universe, to be carried forward without needing to steer, to breathe without needing to explain, to wake without needing to remember where the dream ended and the day began. The same laws that govern the stars have written themselves into your cells. The same symmetry that shapes time shapes the curve of your sleep. So when you open your eyes, do it gently. The world will still be spinning, the light still travelling, the story still unfolding. You will still be in motion, even in stillness, even in thought. And tonight, when darkness returns, it will not be an ending. It will be a continuation, another breath in the long conversation between you and the cosmos. Another quiet moment for wonder to settle, and for mystery to hum softly beneath your pulse. So rest and rise and rest again. That rhythm of motion, of change, of curiosity, is the heartbeat of existence itself. You're not apart from it. You're the note it plays, however brief, however bright. And somewhere, light is still moving. Time is still unfolding. The story, like you, is still alive, endlessly, beautifully in motion,